Hello, this is Mr. Copeland coming from you live from my living room. So, today we're going to talk about dilations. I'm going to give you an assignment about dilations after this, so it'd be beneficial to read through this first as you're practicing that dilation assignment. If you're looking at this, we're at 10.1 and we are at page 316 and 317 of your textbook. If you wanted to look at it online, or if you wanted to look on the hard copy version, either way, it's the same thing. So feel free to follow along with us. We were talking about dilations, and dilations we talked about a little bit before we went on spring break, and dilations were a type of transformation. There were reflections, rotations, translations that moved things around and kept things congruent. They didn't change their size or shape. But for dilations, they do change their size. Same shape, but different sizes. If you look, there's these rockets over here that are definitely the same rocket, but bigger or smaller. Okay? And what dilations do is as things get closer or farther away from the center of dilation, they get either bigger or smaller. And the center of dilation in 8th grade will always be the origin. Okay? It won't be anywhere else on the graph. It'll always be at the origin. Okay? Center of the graph, center of dilation. So as things get closer and further away from the origin, things will get bigger or smaller. So I'm going to scroll down a little bit here. So we have these two triangles here, this blue triangle, RST, and this green triangle, R prime, S prime, T prime. If you remember, those little primes on top of those letters mean that it's the second version. So it started with the blue and moved to the green. Okay, so you can tell that it got bigger, right? You can tell it got bigger, but we want to know exactly how big and how we can kind of see that. So what this table is asking us to do is to kind of measure these distances and figure that out. So if I look and try to measure this out, CR, well, actually, this is CR prime. So CR prime goes all the way from here to here. And using my magical ruler, I can tell that that's 5 millimeters. Now, if I try to measure C to R, that's this distance here, that's only 2.5 millimeters. And if I divide those distances, just like I have on this little fraction here, the red divided by the blue, I'm going to get 2, because 2.5 is only half of 5. So it takes 2 of those to make this. And so I'm going to measure these other distances as well. And if I do the same thing for the other distances, bam, I'm fast. So now if I measure this, that's C to S prime is 4, C to S is 2, that's half again, same kind of ratio here, and that it is, if I divide, I'll get 2. Okay, so 4 divided by 2 is 2. And if I try the same thing, for this last segment here, for CT and CT prime, you'll see that it's 6 and 3, which again makes the same ratio, 2. So the big conjecture here at the end is that this ratio is the same. It's 2 every time. And if you see here in a much better written, better handwriting on the computer, you can see these distances and that ratio is always the same. It's 2. The ratios are all equal. When we dilate something, the size of everything moves together, and the size of these shapes, the size of the distances will all double. Okay. Now, obviously, that can change from doubling if we use a different scale factor. So on this one, it's going to be different. Instead of getting twice as big, you can see it goes from A to A prime in here, and it gets smaller. Okay, so this shape is going in, and now you can see how this shape is kind of going in together towards the origin. All right, so as it's going in, we're going to look at these. Oh man, those arrows do not line up anymore as I scroll. So we're going to look at these ordered pairs and see what that does to those ordered pairs on this. So let me clear that. And what I'm going to do is I'm going to put down these ordered pairs for B, C, D, A, and show how the ordered pairs translate. And not just the side lengths and those lengths do, but also the ordered pairs. So for B and B prime, I'm going to start with B. The X value here, it looks like it's 1, 2, 3, 4 to the right. So for the X value on B, I'm going to put 4. And for the Y value, that goes up 2. So I'm going to put 2. Now I'm going to look at B prime. And so I'm going to erase this coloring. And now for B prime, I'm going 2 for the X value. And I'm going to go up 1. So now you can see from B, we had 4, 2. And from B prime, 2, 1. Now this ratio here, you can see it went by half. So 4 became 2. 2 became 1. So this is 1 over 2, or 0.5, whichever you like more. 0.5 was actually a little bit easier for me to write, so I'm writing that again. So 0.5, so these ordered pairs got cut in half, just like the distances would as well. And now you can see, as I magically made all this rest of this appear and cleared out my handwriting, this ratio stays the same for all these ordered pairs. 5 becomes 2.5. -2 becomes -1. -4 becomes -2. These are all getting divided by 2, so you can put a half, the fraction, like I did before, or you can put this decimal, 0.5. Both of these are correct answers in this case, okay? And what happens a lot is if you get bigger, you're going to be multiplying by numbers that are greater than 1, okay, to make things bigger. But if you use numbers smaller than 1, it'll get smaller. So I'm going to find a space to write that out. Let's see. So I'm going to write this here. Hopefully it's legible. Okay. But if we have a scale, you know what? I will pause it. Okay, here we go. So scale factor, if it's bigger than 1, the image is going to get bigger. If it's smaller than 1, the image is going to get smaller. So that means, just like earlier when we had a triangle, that was the scale factor was 2, it was getting twice as big. If it's getting 2, 3, 4, 5 times as big, it's going to get bigger. But if we have something like a fraction or a decimal, like 0.9, 0.8, 1/2, 1/3, those are going to get smaller. It's going to get divided by 3. It's going to get smaller and smaller, okay? And so I want to talk a little bit more about that scale factor, and not only what it means, but also how to find it. So a scale factor is something that can enlarge or reduce an image, okay? That's that number that we're using, that ratio from these different images. From the beginning to the end, there's going to be a scale factor. And just like we kind of used it and found it in some of these other ones, you can see a scale factor being used in these different images. So I'm going to take this one and show you guys how to kind of use it yourself, or to find it from a picture like this. We have the image and the after image. We have both the pre-image and the post. So what we're trying to do here is find out what the scale factor is. I can check every single point if I want to, but we've already showed earlier that the dilations work as a group. So same thing will happen to every single point. So I'm going to take point D here and D prime, and I'm going to look and see. It looks like the X value is 4, and up here is 10. So we have 4, 10 for point D. And now if I go and make a point for D prime, purple will be good. Go over to 2 and up to 5. So now we have 4, 2, 10 to 5. That's how these points moved. The values were 4 to 2 and 10 to 5 during this dilation. So think to yourself, did this get bigger or did it get smaller? we can look at this rectangle and we can see that this rectangle got smaller. We can see that these numbers got smaller. So we know it's going to be less than 1. Whatever this number is, it's going to be less than 1. Okay. And this number, we'll have to look and see if we could make a fraction out of it. What would it be? 4 divided by 2, okay, would give us 2. 10 divided by 2 would give us 5. So we want to have 1 over 2. And I think the actual version for this textbook uses 0.5 because they like decimals more than fractions, I suppose. So we have the scale factor is 0.5. That's how much we're going to multiply by these points to get these new points. And if I multiplied 10 times 0.5, I'd get 5. 4 times 0.5, I'd get 2. Works with a fraction or the decimal. So this is it for our introduction to dilations and giving you guys a little intro to what this means. Dilations are something that we'll use a little bit of, and you'll have an assignment to work on now. What I want you to remember, since this is the first video I'm making, I want to make sure that you guys know you can pause, rewind, stop. If I'm going too fast, too slow, you can change the speed on the YouTube video. You can do whatever you need. You can have this playing and refer back to it as much as you want while you're doing those assignments, okay? Do not feel like this is a one and done kind of thing. Use it. It's much better than in person. You don't have to worry about me going too fast or too slow. Pause it and you can keep going. Thanks, guys. Have a good day.